Hey everybody, this is Larry. This is day 26 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord looking for free coins. Let me know what you think about today's farm. Cheapest flights within K stops. Yeah, hit the like button, hit the subscribe button, join me on Discord. I don't know if I already said it. Man, I am so out of it that I don't know. But okay, let's see. So this looks like a shortest path farm just from the title, because generally that's what it goes. But let's see, there are end cities connected by some number of flights. You're giving away flights where basically it's a asymmetric graph with an edge weight. So from the two, you're given 3 integers, source, distance, and k. Return the cheapest price from source to distance with at most k stops. If there's no such route, return -1. This is actually and it's only 100. I mean, this is kind of tricky in that there is pretty. I mean, I think this is standard Dijkstra theory. I don't know why I say theory, but I've been watching too many of those chess videos where everyone talks about theory and whatever. But no, I mean, I think this is just Dijkstra or Dijkstra, depending on, I don't know, I feel like whichever way I say it, you'll correct me. But basically with the number of stops is one of the parameter, and then you can kind of think about it as a graph where instead of just one graph, each node also contains, and this is something that comes up in dynamic programming as well, but in this case, it's a little bit different in that you're exploring the graph in a way, in a greedy kind of way, which is something that Dijkstra is built off. But this is again the shortest path problem, and you can kind of think about. I didn't finish talking about the part about the dual, but basically you can think about instead of one graph, you can think about each path transition as to an equivalent graph where there are k of these graphs, or maybe k plus 1 of these graphs, and then you kind of draw an edge from say, for example, from 0 with 0 stops to 1 with 1 stop, and so forth, right? So you can kind of build the graph that way in your mind, and then extend an extra dimension. And this is something that comes up, as I mentioned, as a spoiler thing, comes up quite a bit in dynamic programming. So that is definitely a technique that you should get familiar with. And with that, and of course, part of that is that we don't have to create an explicit graph of what we just said. We can use a sort of an implied version of this graph. Basically, another way to phrase it is that for each node, we contain k plus 1 nodes, if you will, maybe. Basically, like, what's the cheapest way to get to node 0 with 0 stops? What's the cheapest way to get to node 0 with 1 stop, 2 stop, 3 stop, ... all the way to k stops? And those are the states that we take care of. So that's basically the idea behind the algorithm behind that problem. Here, I hope I'm not wrong in the sense that this is the part where I come up with this idea, this algorithm, this theory, and then we go into the constraints to see if it fits, right? So basically, we are saying that this n and the number of edges is going to be, well, just like a full graph, n square, or n choose 2, if you will. Though, that's a little bit weird, I guess. It should be n square, right? Because it's asymmetric, but like in theory, it could have an n square. Well, I guess n square minus n, because you can't have a stop to itself, but right, and that is just n minus 1 times n, right? So I don't know why this is divided by 2. Maybe that's just anyway. So actually, that's sorry, I got caught a little bit because I thought that was really odd, or at least a weird constraint, but maybe that's fine. It doesn't change anything anyway, right? So Dijkstra will, if you know the literature, we're running v log e, which is roughly v log v. If we'll maybe do the proof later, but then here it's the nodes, instead of just re for the nodes, which is the number of re is equal to n, you may say, but as in our new graph, re is actually n times k, but and the number of edges is also n squared times k, say, but that's still fine, because then we have n times k times log of n squared times k, which, you know, you remove the 2 because it goes, you know, because that's how log works, and then yeah, and then, you know, this should be fine, because n times k is going to be, and where is k? Oh yeah, k is less than n, so this is just going to be 10,000 log 10,000, 10,000, or, you know, log of 10,000 is what, like 14 or something. So yeah, so 14 times 10,000 is going to be fast enough, so I don't worry about it that much in theory. This is Leetcode after all, so we'll see. But yeah, but that's basically the idea of what we're trying to do here, right? Okay, so now we have an idea. How do we implement it? This is basically straight Dijkstra. So first of all, let me do an adjacency list. I just like it a little bit better that way. So we convert for UV price in flights, adjacency list of u dot append v price. Okay, and now we have the adjacency list. I'm just too used to big N, so I'll make it a big N. And then now we said best is equal, just distances is equal to, I'm going to cheat a little bit by using set, because I mean, there's so what's going on in my head is that I'm just trying to think about whether I should use n times k matrix versus a set, or in this case a dictionary, really, not a set. Sorry, a little bit imprecise there. And my idea is that a lot of those states are not going to be reached, so I don't want to spend the time allocating the memory. But again, 100 times 100 is 10,000, is probably not a big deal either way, and you do pay a cost on dictionary. But anyway, that's a very small thing relatively, so I don't mean to dwell on it, but I just want to kind of disclose what goes on my head, even for that brief half a second. And I don't think it matters either way, which is why I'm like, whatever, just do it this way. And yeah, and then we set distance of the source. The k is equal to 0 is equal to 0, right? Oops, because this is where we start, and we want to put that in a heap, right? So h is equal to and then maybe that what was it? Push. We push into the heap. What do we want to push? We want to push the distance first, and doesn't really matter how many k's that is in the final. So, but I'll put the k second, and then the source last. Like I said, it doesn't really matter. And I am going to actually abstract this just slightly by putting it as, is it NQ? I forget what the name is for Dijkstra. Relax. I mean, relax is what you do to the node, but yeah. Anyway, I guess it doesn't really matter. A source, or not source. So we want the distance, we want the current node, and we want the current k, right? So then now this is node, and this, as you can see, makes this actually more readable, right? It's like, what are these zeros? No one knows. I already forgot. So yeah, and maybe we can even just put use this as maybe in Q, and then if node k is in distances, then, or if node k is not in distances, or distances of node k is greater than d, then we have to do an update. Then now, well, we have to maybe in Q. I forget the name, so sorry if you should probably use a better name for it. 0 and 0, right? All right. So then while the heap is less than 0, we have heap q dot heap pop. We could also use a maybe deq or actual deq, but this is pretty. I mean, if we use it again, then maybe I'll do it. But node k, oh no, dk node is equal to this. Again, this is a min heap, so then it'll be sorted by the distance, which is what we want anyway, right? So then now, if node is equal to the destination, we return d. And there is some distinction for distro that we have to return here and not in queue, because the first time you enqueue it may not be the shortest distance. There is some nuance there. And then the other thing is if node of k, and you know that this is in it because it's so enqueued, if this is less than d, we continue. Basically, I don't go over this too often. Maybe I need to at some point. This is actually a known thing by a lot of competitive people, but it doesn't really, like, if this is your first time seeing it, you may easily miss this. The idea here is that there are two versions of Dijkstra, and not two versions of Dijkstra per se. Maybe that's a wrong phrasing. But basically, if you read up on Dijkstra, and I should actually just put up here so then you can Google and read up on it as well. It is actually all of relog re. So why do I say it's relog ye, right? The reason is because the relog re version has this thing that allows you to modify variables of stuff in the heap as it is in the heap. Not going to go into that much detail, but hopefully that is sufficient for understanding. And what I mean by that is that, okay, let's say let's say looking at this graph, right? 1 updates the distance for 3, and then 2 updates the distance for 3. In that update, you only have 1 entry of 3 in the heap in that case, right? Because you have direct access to that node, and it makes the thing more complicated, because then now you have to, not a heapify, but you have to basically redo not the entire heap, but you have to update the heap. I think it's a heap up in this case for heap down, but for min, but you have to do the min heap, you have to do a heap up after you do every update. So there's this idea of an operation of called update heap for a given thing that's already in the heap, right? But the way that a lot of people actually do it in competitive, and that I'm doing here, is that we actually do the relog ye thing, where instead of doing what we just said about updating values that are already in the heap, because the heap, you have to have the heap API in most languages do not have this update heap function, for reasons that I'm not going to get into, but that's basically why. So the way that people do it is that for every edge we just add an extra thing into the heap, right? So that in that case we will have a lot more things in the heap, because, for example, in this case, if we update 1 going to 3 and then 2 going to 3, looking at this example 1, then now you have 2 cases of 3 into the heap with 2 different distances, right? And if you don't have someone like this, you may, in the past, or you could try it even, right? I mean, may not work for every problem's not the same, and I don't know how they set up the test cases, but yeah, you may run into TLE. Why? Because in that case, so the core part about this relog ye is that there's still the re part, right? And what do I mean by the re part? It means that for every node, we only relax once, meaning that we only process this node once. If we don't have this, then you may process a node for multiple different distances, depending on which one updated, right? So that's basically the idea. And why are people usually okay with this thing? Well, all of relog ye, we know that ye, depending on the kind of graphs, but in a lot of the graphs where there's no multi-edges, in that case you can probably eliminate some anyway. Or there are no multi-edges, there's no sub loops, etc. Well, ye is going to be at most v to the v square, which, as we talked about, because of the log v square, you could take this out to be all of 2v log v, which is obviously just twice the slope, but with the complexity. And of course, in the big O analysis, you can take away the 2, kind of, depending on how you want to write it, right? So that's basically the idea, and that's something that if you see this in Dijkstra, it will, you may not realize to write it, but that's something that comes up well every time you write Dijkstra, really, to be honest. But some problems are just not like the test cases may not be strong enough, and you may be able to get away with it. But definitely, it's not. You need to do this. Okay, and then now we have for v in what do I call it? Adjacency list of node. Yeah. I was trying to see if I needed to use the k, but of course we're talking about implicit graphs, so that's fine, right? So then now we do a maybe and q on v, k plus 1 because the hop updated, and then d plus what do we call it? Oh, I messed this up because the price is actually in here. So then p for price, and then d plus p is the price, and that's pretty much it, I think. And then if we cannot get it, return -1. Oh, there's one more thing that we have to do, that we can either, because we already have it here, we might as well do it here, which is that we have to check that this k is less than this k. So maybe my variable name choices, whatever. But yeah. So okay. Dum dum dum. Oh, my parents are weird because I have an or. Forgot how. I wasn't paying attention. All right. Well. Well, it's kind of weird. It's not that embarrassing. It's fine. It happens a lot, actually, right? But I was gonna say, like, it's embarrassing when you say all these things and your code as well. Let's kind of see what is happening here. Okay. DK node. Wait. So it's not going here at all. Did I mess up the? No, it's still limit or still indexed. So why is it not is this did I mess this up? This D is let's see. That's weird, but okay, let's take a look. Okay, so that's good. Yeah, so okay, so it does go here. Okay, so then what am I doing? Maybe usually it's just a typo, but I'm really confused right now. So it goes to node 1 and then with a cost of 100, right? But then it doesn't actually. So did I mess it up? 100 and node 1. So this should not be in there. So this should be true, and k should, and that's weird. Definitely, it definitely is probably a typo somewhere, but I'm just confused. Okay, so then it goes to oh, wait, what does this mean? This means that there's already distance in there, and it's greater. No, that's right. Then why? Tell me why. Did I make it? What does this stop? Did I misunderstood something? Like if there's only one stop from 0 to 2. Oh, I see. I mean that's fine. I just think I mean I know what to. So it doesn't count the last thing as a stop. So maybe we can do something. I mean that. I think we can just do this as because I think I just understood it that way. Maybe not. Huh. What am I doing wrong? Tell me way to K and max K. What just because I did something silly with using these silly variable names? Oh, I see. It's silly because this should be equal to because I am silly. Okay, now it's good. Man, really do a lot of silly things though. I mean, I was wrong in 2 places, but basically, the definition of a stop is an intermediate stop. So you can say that, you know, my K is actually the distance, though there's also D and the price is being the distance, so it's a little bit confusing here. But it just means that if there's one stop, then you're taking 2 nodes, 3 nodes, and if you want to count the initial one. So that's why I have the +1 here. And I don't know why I wrote has to be strictly equal to. But yeah, now that we kind of fixed that, we can hit submit. What a silliness. Cool. 1031. We already talked about complexity because this is just Dijkstra. Well, this part specifically. So yeah, I don't really have much more to say about this one, but hopefully, you know, I mean, I took my time with explanation on this one, so definitely let me know. What did past Larry do? Well, yeah, I mean, did the same thing, pretty much. More or less exactly the same, but I think this time I spent time explaining this part a little bit. Okay, that's all I have for this one. Let me know what you think. Stay good, stay healthy, to good mental health. Have a great rest of the week. I'll see you later and take care. Bye bye.